January 17, 1944, Wilhelmshaven, northern Germany, 03:47 hours. The radar operator's fingers trembled against the cold metal of the Würzburg-Riese control panel. In the concrete bunker beneath the frozen earth, the air tasted of machine oil and stale cigarette smoke. The cathode ray tube before him glowed an eerie green, casting shadows across his gaunt face. Oberleutnant Klaus Hartmann had been stationed at this Luftwaffe early warning post for 18 months, and in that time he had learned to read the electronic pulses like a priest reads scripture. Each blip represented tons of aluminum and flesh hurtling through the darkness at 200 miles per hour. Each signal meant a chance to vector night fighters toward their prey, to send another American bomber spiraling into the North Sea in flames. But tonight, something was different. At 03:51, the screen showed what Hartmann expected, a formation of contacts approaching from the west, 70 miles out, over the dark waters. Heavy bombers, certainly. Americans, almost certainly. The 8th Air Force had been pounding German industrial targets with increasing ferocity since the beginning of 1944, and Wilhelmshaven, with its critical U-boat pens and naval facilities, remained a priority target. Hartmann reached for the telephone to alert the Fighter Control Center at Stade. His hand was halfway to the receiver when the impossible happened. The signals vanished, not gradually, fading as aircraft turned away or descended below the radar horizon. They simply ceased to exist, as if God himself had reached down and erased them from the sky. Hartmann's breath caught in his throat. He tapped the screen with his knuckle, convinced the tube had failed, but the ground clutter remained visible, the familiar electronic noise that confirmed the system functioned normally. The bombers were simply gone. Within seconds, they reappeared. Closer now, 50 miles out, still approaching. Then, they vanished again. Hartmann felt something cold settle in his stomach, something that had nothing to do with the winter temperature in the bunker. In 18 months of reading these screens through countless raids and hundreds of contacts, he had never seen anything like this. The Americans were doing something new, something his training had never prepared him for. And in that moment, staring at the flickering green screen that suddenly seemed as unreliable as a fortune-teller's crystal ball, Klaus Hartmann understood that the war he thought he knew was changing into something else entirely. The radar systems that Germany had developed represented the cutting edge of wartime technology, the electronic eyes that were supposed to give the Reich the advantage it desperately needed. By 1944, the Luftwaffe operated an intricate network of early warning and fire control radar stations stretching from Norway to the Mediterranean, from the Atlantic Wall to the Eastern Front. These systems, Freya, Würzburg, Mammut, Wassermann, bore names from Germanic mythology, as if invoking ancient gods might somehow protect them from obsolescence. The Germans had pioneered radar development in the late 1930s, and their systems had proven devastatingly effective in the early years of the war. British bombers had fallen by the hundreds to flak, and night fighters guided by these electronic sentinels. The Würzburg-Riese that Hartmann operated was a marvel of German engineering. With its parabolic dish measuring 25 feet in diameter, it could detect aircraft at ranges exceeding 40 miles and determine their altitude, speed, and heading with remarkable precision. The system operated on a wavelength of 53 centimeters, pulsing electromagnetic energy into the sky and listening for the echoes that bounced back from metal aircraft structures. When integrated with the Himmelbett, the four-poster bed system of coordinated radar and ground control, it created a defensive network that theoretically made German airspace a graveyard for enemy bombers. Theoretically. The reality in January 1944 was far more complicated. The American 8th Air Force had been operating from British bases since 1942, initially in small numbers that German defenses handled with relative ease. But by the winter of 1943-44, The Americans were launching raids of unprecedented scale, formations of 500, 600, even 700 heavy bombers protected by swarms of long-range fighters. The German radar operators and fighter controllers found themselves overwhelmed by the sheer quantity of contacts appearing on their screens. Yet the systems themselves remained effective, until suddenly, inexplicably, they didn't. The phenomenon that Klaus Hartmann witnessed that January morning was being reported simultaneously at radar stations across northwestern Germany. At Heligoland, operators watched bomber formations disappear and reappear like ghosts. At stations near Bremen, Hamburg, and Kiel, experienced radar technicians stared in confusion at screens that seemed to have developed minds of their own. Some contacts would vanish entirely for minutes at a time before returning. Others would multiply impossibly, turning a formation of 30 bombers into what appeared to be 300. The electronic landscape that had seemed so reliable, so scientific, so modern, was suddenly as chaotic and unreliable as a medieval battlefield shrouded in fog. What the German radar operators were witnessing was the operational debut of a technology so mundane in appearance that it seemed almost absurd. Strips of aluminum foil cut to precise lengths and dropped by the thousands from American bombers. The British had codenamed it Window. The Americans called it chaff. The Germans would come to know it as Duple, and it would fundamentally alter the electronic warfare landscape for the remainder of the conflict and beyond. The concept was deceptively simple. Radar systems detect aircraft by sending out electromagnetic pulses and measuring the reflections that bounce back from metal surfaces. A strip of aluminum foil cut to half the wavelength of the radar frequency would resonate when struck by radar energy and create a reflection indistinguishable from that of an actual aircraft. Dropped in sufficient quantities, these strips would create a cloud of false targets that could obscure genuine aircraft, saturate radar displays, or create phantom formations where none existed. The technology required no sophisticated electronics, no rare materials, no elaborate manufacturing processes. It was, in essence, Christmas tinsel weaponized into one of the most effective countermeasures of the entire war. Both sides had discovered the principle years earlier. British scientists working at the Telecommunications Research Establishment had demonstrated the concept in 1942. German researchers had independently developed the same understanding, but both nations had initially refused to deploy the technology, locked in a prisoner's dilemma of mutual deterrence. Whichever side introduced chaff first would temporarily blind the enemy's radar, but would also reveal the technique, allowing the enemy to do the same thing in return. For the British, this seemed like a catastrophic trade-off. The Luftwaffe might no longer bomb with the accuracy that radar-directed defenses prevented, but German bombers could then blind British radar and strike with impunity. For the Germans, the calculation was similar. Why give the Allies a weapon that could neutralize the sophisticated radar systems that represented years of research and massive industrial investment? The stalemate broke in July 1943 when the Royal Air Force deployed Window during a devastating raid on Hamburg. The results were so dramatic that they bordered on the apocalyptic. German radar operators watched their screens fill with thousands of false contacts, making it impossible to vector fighters toward genuine targets. The raid killed an estimated 42,000 German civilians and effectively demonstrated that chaff could negate even the most sophisticated air defense system. The Americans, observing the British success, accelerated their own chaff program. By January 1944, B-17 and B-24 crews were carrying bundles of aluminum strips on every mission over Germany. Each strip measured precisely 27 centimeters long, half the wavelength of the Würzburg radar that formed the backbone of German air defenses. The strips were bound in packages of 2,000, and each bomber carried hundreds of these packages. At intervals calculated to maintain continuous coverage, crew members would cut the twine binding the packages and feed the strips into the slipstream through specially installed chutes. The aluminum would separate and flutter down through the sky in vast metallic clouds, each strip tumbling and rotating, each creating its own radar return. The psychological impact on German radar operators, like Klaus Hartmann, was profound and multifaceted. These men had been trained to trust their equipment absolutely. In the chaotic environment of wartime air defense, where split-second decisions meant the difference between successful interceptions and catastrophic losses, the radar screen represented objective truth. It showed what was real. It transformed the invisible sky into comprehensible information. An operator's job was to read the screen correctly and communicate that information accurately to fighter controllers. The skill lay in interpretation and communication, not in questioning whether the screen itself could be trusted. Chaff shattered that certainty. Suddenly, the screen could not be trusted. The contacts might be real or might be phantoms. A formation that appeared to number 100 bombers might actually be 30 aircraft hidden within a cloud of aluminum. Or it might actually be 100 bombers, and treating it as a deception could lead to catastrophic failure to respond. The radar operators found themselves thrust into a new kind of warfare where the primary battle was epistemological, a fight to determine what was real and what was illusion. Hartmann's experience that January morning was repeated thousands of times across Germany as 1944 progressed. The Americans quickly refined their chaff deployment techniques. Initial drops had been relatively crude, simple saturation that created obvious clouds of clutter on radar screens. But American electronic warfare specialists soon developed more sophisticated tactics. They learned to drop chaff in patterns that mimicked genuine bomber formations, complete with realistic spacing and movement. They deployed it selectively, sometimes obscuring only portions of a formation to make it appear that aircraft were changing course. They coordinated chaff drops with actual diversionary formations, creating layers of deception that German operators struggled to penetrate. The Germans responded with desperate ingenuity. Radar technicians learned to distinguish chaff clouds from actual aircraft by subtle differences in return characteristics. Chaff signals flickered and faded more rapidly than solid aircraft. Operators were trained to look for these telltale signs, to compare returns across multiple radar frequencies, to correlate radar data with visual observations and radio intelligence. New radar systems were developed that operated on different wavelengths, less susceptible to the standard chaff configurations. The Mannheim Giant and the Wassermann systems represented German attempts to stay ahead in the electronic arms race. But the fundamental advantage had shifted. The Americans possessed industrial capacity that Germany could not match. For every modification Germany made to its radar systems, the Americans could produce new chaff specifications by the ton. A B-17 bomber carried approximately 2,000 pounds of aluminum chaff on a typical mission in 1944, enough to create tens of thousands of false targets. With 500 bombers dropping chaff simultaneously, the Americans could generate millions of radar returns, overwhelming any processing system the Germans could deploy. The aluminum itself became a symbol of American material abundance, as significant in its way as the bombers that carried it. Each strip represented a tiny fragment of American industrial capacity, bauxite mined in Arkansas or Jamaica, refined into aluminum in plants powered by hydroelectric dams in the Pacific Northwest, rolled into foil in factories that had been manufacturing household products just years earlier. The fact that Americans could afford to drop tons of processed aluminum over Germany, using it once and discarding it like trash, spoke to a productive capacity that Germany simply could not comprehend or counter. German soldiers and civilians collecting the aluminum strips after raids initially thought they might have intelligence value. Perhaps the markings or composition could reveal something about American manufacturing. But analysis revealed only what German intelligence already knew and feared. This was standard industrial aluminum foil, produced with the kind of quality control and consistency that came from mature, undamaged industrial infrastructure. There were no shortcuts, no signs of resource scarcity, no indication that American production was straining to meet demands. The chaff was manufactured with the same casual excellence that characterized American razor blades, canned food, and nylon stockings, products that represented a civilian economy so productive it could wage total war while maintaining living standards that Germans could barely imagine. For the radar operators in their concrete bunkers, this realization was more demoralizing than the chaff itself. Hartmann and his colleagues had been told that Germany's technological sophistication would overcome Allied numerical superiority. The Würzburg radar was supposed to be that technological edge, a system so advanced that quantity could not defeat quality. But here was the enemy defeating sophistication with brute abundance, rendering advanced technology obsolete through the simple expedient of throwing resources at the problem until it disappeared. The operational reports from German radar stations in early 1944 read like accounts of psychological dissolution. Operators reported hallucinations, convinced they saw patterns in the chaos that weren't there. Some became paranoid, believing the Americans had developed new invisible aircraft that left no radar signature at all. Others went to the opposite extreme, trusting nothing, reporting no contacts for fear of being fooled by decoys. The careful training that had produced skilled, confident radar operators was undermined by an enemy that could make their most sophisticated equipment unreliable. Fighter pilots reported similar confusion. A Messerschmitt Bf-110 night fighter pilot named Hans Joachim Jabs, who would survive the war with 50 confirmed kills, described his experience being vectored toward bomber formations in early 1944. The controller would report 100-plus contacts at 30,000 feet. We would climb to intercept altitude, burning precious fuel, only to arrive and find empty sky filled with shimmering aluminum. Sometimes the bombers were there, but miles away from where the radar indicated. Other times, we would be directed away from genuine formations toward phantom targets. The Americans had turned our own technology against us, and we began to trust the Mark I eyeball more than the sophisticated electronics that were supposed to give us the advantage. The psychological warfare dimension of chaff extended beyond operational confusion. German propaganda had spent years promoting the image of technological superiority, precision engineering, advanced weaponry, scientific prowess that would inevitably triumph over numerically superior but supposedly less innovative enemies. The V-weapons, the jet aircraft, the advanced U-boats, these were supposed to be war-winning technologies that demonstrated German genius. Radar systems fit perfectly into this narrative. They were invisible, mysterious, sophisticated devices that gave German defenders godlike awareness of enemy movements. Chaff exposed this narrative as hollow. The Americans had taken Germany's most advanced defensive technology and negated it with metal foil, a product so simple that German housewives had used it for wrapping Christmas cookies. The psychological message was unmistakable. American industrial abundance could overwhelm German sophistication through sheer material weight. No matter how advanced German technology became, the Americans could flood the zone with enough countermeasures to make it irrelevant. This realization rippled through German military culture in ways that transcended the immediate tactical problem. Officers who had believed in technological salvation began to understand that industrial capacity mattered more than individual innovations. The Wunderwaffen, the wonder weapons, that were supposed to reverse German fortunes looked increasingly like desperate attempts to find a technological shortcut around material inferiority. The V-1 flying bomb was impressive, but the Allies could afford to lose thousands of buildings to V-1 strikes while continuing to prosecute the war with undiminished intensity. The Me-262 jet fighter was the most advanced aircraft in the sky, but there was never enough fuel to fly them in decisive numbers, never enough pilots to man them, never enough spare parts to keep them operational. Hartmann's bunker became a kind of meditation chamber where these uncomfortable truths were confronted nightly. The Würzburg Riese continued to operate, its parabolic dish rotating through the darkness, pulsing electromagnetic energy into the sky. But now every contact had to be questioned, every signal evaluated. For authenticity, the work transformed from technical operation to existential interpretation. What is real? What is deception? Can we trust what we see? These questions haunted the radar operators as Allied bomber streams droned overhead with increasing frequency. The American aircrews, dropping the chaff bundles, rarely considered the psychological impact they were creating. For them, chaff was simply another piece of equipment, like oxygen masks or flak jackets, something that improved survival odds and got loaded aboard as routinely as ammunition and fuel. A B-17 waist gunner named Robert Morgan, flying missions out of Bassingbourn in early 1944, recalled, "We had these packages of tinsel, we called it. Somebody in the crew would shove them out through the flare chute at regular intervals. We never thought much about it beyond knowing it was supposed to confuse German radar. It seemed like magic, like we were making ourselves invisible, but mainly we were focused on keeping the formation tight, watching for fighters, preparing for the flak barrage over the target. The chaff was just one more thing on the checklist." This casual American attitude toward what Germans perceived as devastating psychological warfare was itself a form of psychological warfare. The ease with which Americans deployed sophisticated countermeasures, the routine nature of operations that disrupted German defensive systems, spoke to the depth of American military capability. These were not desperate measures deployed in crisis. This was standard operating procedure, the kind of thing that happened on every mission as a matter of course. The implication was clear. If this was routine, what else might the Americans be capable of when they really needed to innovate? The German High Command struggled to respond strategically. Resources that might have been devoted to new aircraft or improved training went instead into modifying radar systems to counter chaff. New wavelengths required new antenna designs, new receiver configurations, new operator training. Each modification consumed time and material that Germany could not spare. Meanwhile, American intelligence monitored German radar frequencies constantly, ready to produce new chaff specifications the moment Germans shifted to new wavelengths. The electronic warfare cycle accelerated into an arms race that Germany was fundamentally positioned to lose. By the spring of 1944, German air defense doctrine had shifted dramatically. The sophisticated radar-directed system that had seemed so promising in 1942 was being supplemented, and sometimes replaced, by more primitive methods. Visual observers were posted with binoculars and telephones. Sound-ranging equipment was dusted off and redeployed. Fighter pilots were instructed to ignore some radar vectors and hunt independently. These were the tactics of an earlier era, less efficient and less effective than the electronic systems they replaced. But they had one critical advantage. They could not be fooled by aluminum foil floating through the sky. This technological regression was spiritually crushing for German personnel who had believed in modernity and progress. The narrative of German superiority had been built on the idea of advancing into the future while enemies remained mired in the past. Now Germany found itself retreating into less sophisticated methods while the Americans soared overhead with the latest innovations. The psychological impact was similar to what German soldiers experienced facing Soviet T-34 tanks in 1941. the sudden realization that the enemy possessed capabilities that German propaganda had insisted were impossible. Hartmann continued operating his Würzburg-Riese through the spring and summer of 1944, watching the invasion of Normandy unfold on his radar screen as Allied aircraft filled the skies with such density that chaff was almost unnecessary. The D-Day landings represented the culmination of Allied material superiority. So many ships, so many aircraft, so many men that German defenses were simply overwhelmed by quantity. The radar station at Wilhelmshaven tracked the bomber streams heading south to support the invasion, impotent to interdict them in any meaningful numbers. By August 1944, with Allied armies advancing across France and Soviet forces crushing Army Group Center in the east, the strategic situation had deteriorated beyond salvage. The radar operators knew it, even if official propaganda refused to acknowledge it. They could read the truth in the electronic signals they monitored, the increasing frequency of raids, the growing size of formations, the presence of long-range American fighters that stayed with the bombers all the way to the target and back. The Luftwaffe was dying. The radar operators were chronicling its death throes in real time, watching their screens fill with contacts they could not counter. On March 15, 1945, Hartmann received orders to destroy the Würzburg-Riese and evacuate as British ground forces approached Wilhelmshaven. He placed demolition charges around the base of the radar dish and in the bunker's electronic equipment. When the charges detonated, the parabolic dish crumpled like aluminum foil, an ironic end for a system that had been defeated by aluminum foil. Hartmann retreated east with other Wehrmacht remnants, eventually surrendering to British forces in early May. After the war, Allied intelligence teams conducted extensive interviews with German radar operators and electronic warfare specialists. The reports they compiled revealed the psychological dimension of the chaff campaign more clearly than any operational analysis could have captured. One anonymous radar operator told his interrogators, "We knew we were beaten when the Americans started throwing away aluminum. In Germany, we recycled every piece of metal, melted down church bells to cast shell casings, salvaged every scrap to keep the war machine running. The Americans were discarding tons of processed aluminum as if it cost nothing. That told us everything we needed to know about who would win the war, not because of courage or ideology or fighting spirit, but because they had so much they could afford to be wasteful with it." This testimony captures something essential about the chaff campaign's psychological impact. The aluminum strips represented more than just a technical countermeasure. They symbolized the vast industrial chasm separating the Allied and Axis war economies by 1944. Germany was strangling under blockade, bombing, and multi-front war, scrounging for every resource. America was producing such abundance that it could afford to treat processed aluminum as single-use material, disposable as tissue paper. The same pattern repeated across every category of war materiel. American soldiers were issued new uniforms when old ones wore out, while German troops patched and repatched the same clothing until it fell apart. American units discarded damaged vehicles rather than repair them because new ones arrived faster than maintenance could be completed. German mechanics performed miracles keeping vehicles operational because replacements were unavailable. American air crews ate hot meals and slept in warm barracks between missions. German crews survived on ersatz coffee and synthetic food supplements while shivering in unheated accommodations. These disparities in daily life created psychological effects that were cumulative and corrosive. German personnel at every level understood intellectually that American industrial capacity exceeded German production, but understanding something intellectually and confronting its implications viscerally were different experiences. Chaff made the abstraction concrete. Every raid dropped physical evidence of American abundance across German territory. Children collected the aluminum strips, Women used them for Christmas decorations in the grim wartime holidays. The strips became an inescapable reminder of enemy material superiority, glittering in trees and gutters throughout German cities. Some German scientists and engineers who worked on radar systems recognized the broader strategic meaning even while the war continued. Werner Heisenberg, the physicist who led German atomic research, was also consulted on electronic warfare problems. In conversations with colleagues that were secretly recorded by Allied intelligence after his capture, Heisenberg reflected on the chaff campaign. They could afford to be crude because they had endless resources. We tried to be sophisticated because we had to extract maximum effect from limited means. But in war, crude abundance often defeats sophisticated scarcity. The Americans proved that conclusively. This observation extended beyond chaff to the broader pattern of American warfare. The industrial systems that produced millions of tons of aluminum chaff also produced tens of thousands of aircraft, hundreds of thousands of trucks, millions of rifles, and quantities of ammunition so vast that American commanders rarely worried about expenditure rates. When General George Patton needed artillery support, he could call for fire missions that would exhaust a German army's monthly shell allocation in a single afternoon. When American bomber commanders planned missions, they calculated acceptable loss rates in percentages rather than absolute numbers, because replacement aircraft arrived in steady streams that made losses statistically manageable rather than strategically catastrophic. The psychological dimension of this abundance warfare extended beyond material calculations into the realm of morale and hope. German soldiers and civilians could endure hardship if they believed sacrifice would lead to victory. But by 1944, the evidence of enemy abundance was so overwhelming that sustaining hope required willful delusion. Every bomber stream dropping aluminum chaff was a flying demonstration that Germany could not win through attrition. The Americans could lose 10 bombers, 20 bombers, 50 bombers per mission, and return the next day with formations just as large. Germany was destroying American aircraft at rates that would have crippled any European nation, and yet the attacks intensified rather than diminishing. This was the psychological breaking point for many German military personnel, not the defeat in any single battle, but the realization that no level of German success could alter the strategic trajectory. Even when German fighters shot down bombers in dramatic numbers, as happened during the October 14, 1943, Schweinfurt raid, where the 8th Air Force lost 60 bombers, the Americans absorbed the losses and continued operations. The raid that should have been a cautionary disaster became just another date in the relentless campaign. The aluminum chaff fluttered down over Germany regardless of loss rates, regardless of tactical victories, regardless of anything the Luftwaffe could do. Klaus Hartmann survived the war and returned to civilian life in a Germany that bore little resemblance to the nation he had known. In the 1950s, he worked as an electrical engineer in the rebuilding Ruhr industrial region. He never spoke publicly about his wartime service until interviewed by a military historian in 1978. By then, an old man reflecting on events 3 decades past, Hartmann could articulate what he had felt but not fully understood in that January morning bunker when the radar contacts first vanished. We believed we were the advanced civilization, the modern people with science and technology on our side. We believed the Allies were numerous but backward, rich but uncreative. The chaff taught us we were wrong about everything. They were more advanced, more creative, and so rich that they could implement solutions we couldn't even afford to imagine. When I saw my radar screen fill with false contacts, I knew we were watching the future defeat the past. We were the past. We just didn't want to admit it yet. This confession captures the final psychological dimension of the chaff campaign, its role in demolishing German ideological certainty. The Nazi regime had constructed an elaborate mythology around German racial and cultural superiority, technological prowess, and historical destiny. Every element of this mythology crumbled under the weight of American material abundance. The chaff was not just defeating radar systems. It was defeating belief systems, worldviews, the psychological frameworks that made continued resistance seem meaningful rather than merely suicidal. In the decades after the war, chaff became a standard component of military operations worldwide, evolving into increasingly sophisticated forms. Modern chaff includes precisely engineered fibers designed to defeat specific radar frequencies, deployable in complex patterns by automated systems. The principle remains identical to the 1944 aluminum strips, create false targets to obscure real ones, but the implementation has grown vastly more elaborate. Every military aircraft carries chaff dispensers. Naval vessels deploy it to confuse anti-ship missiles. The technology that first appeared over Germany in 1943 has become so ubiquitous that it's difficult to imagine electronic warfare without it. But the original chaff campaign retains historical significance beyond its technical innovation. It represents a case study in how wars are won not just through courage or tactics, but through the grinding power of industrial production deployed intelligently. The aluminum strips were not a wonder weapon. They did not win battles through dramatic effectiveness. They won through cumulative erosion of enemy capabilities, making sophisticated systems unreliable, forcing opponents into technological regression, demonstrating material superiority in ways that were psychologically devastating precisely because they were so mundane. The radar operators who watched their screens fill with false contacts were confronting a truth that transcended military technology. They were seeing evidence of a society so productive that it could wage total war while maintaining civilian prosperity. Germany had mobilized completely, extracting every possible resource from its population and conquered territories, yet it could not match American output. The United States fought a two-front war across two oceans while simultaneously supplying allies, conducting unprecedented research programs like the Manhattan Project, and maintaining living standards that allowed civilian consumption to actually increase during wartime. This disparity had profound implications for post-war geopolitics. The American model of liberal capitalism demonstrated through wartime production that democratic societies could mobilize resources as effectively as totalitarian regimes while preserving individual freedoms. The Soviet Union would match American production in some categories through forced industrialization, but at catastrophic human cost. Germany, despite its supposed efficiency and discipline, could not approach Allied output. The chaff campaign was a small tactical element in a much larger demonstration that democracy and abundance were not weaknesses but sources of strength. The aluminum strips fluttering down over German cities in 1944 carried this message on every reflective surface: you cannot win, you do not have enough. We can afford to be wasteful. We can throw away what you would treasure. We are so rich that our trash defeats your sophistication. This psychological warfare was perhaps more effective than any propaganda message because it was materially undeniable. German civilians and soldiers could dismiss radio broadcasts and leaflets as lies, but they could not ignore the physical evidence of American abundance that literally fell from the sky. In the end, the radar operators like Klaus Hartmann were witnesses to the transformation of warfare into industrial production. The romantic notions of combat, courage, honor, tactical brilliance still mattered in individual moments, but the war's outcome was determined in factories and on assembly lines far from any battlefield. The side that could produce more aircraft, more shells, more aluminum strips would prevail, regardless of tactical skill. This was total war's ultimate lesson, and it was a lesson that many German military professionals found spiritually devastating because it reduced war from an art to an accounting exercise. The Würzburg-Riese radar systems that once represented cutting-edge technology became museum pieces after the war, monuments to a defeated belief system that had placed faith in quality over quantity, sophistication over abundance. Allied forces captured many intact systems and studied them carefully. American and British engineers were impressed by German design elegance, but noted that it would have been cheaper and more effective to build larger numbers of simpler systems. The German approach reflected a mindset shaped by scarcity. Make each unit as capable as possible, because there will never be enough units. The American approach reflected abundance. Make systems simple and producible, then overwhelm problems with quantity. These opposing philosophies extended beyond radar to every aspect of military technology. German tanks were mechanical marvels, each built like a precision instrument. American tanks were simpler and less individually capable, but produced in numbers that made them strategically superior. German aircraft featured advanced aerodynamics and powerful engines, but were assembled by skilled craftsmen in small quantities. American aircraft prioritized manufacturability, with designs that could be mass-produced by semi-skilled workers in purpose-built factories. The chaff campaign exemplified this pattern perfectly. Elegant German radar, negated by simple American countermeasures, produced in overwhelming quantities. For the soldiers and civilians who experienced the bombing campaigns, the aluminum strips became part of the sensory landscape of defeat. They crunched underfoot in the rubble of destroyed cities. They tangled in the bare branches of trees in the hard winter of 1944-45. They glittered in the ash and dust that coated everything after major raids. Children made toys from them. Old women collected them for recycling that never came. Soldiers cursed them as they tried to clear streets. The chaff was everywhere, inescapable evidence of American technological and material dominance. On the other side of the battle line, American air crews dropping the chaff bundles rarely thought about the psychological effects they were creating. They focused on survival, keeping formations tight, watching for fighters, navigating through flak. The chaff was just equipment, one more thing in the checklist of procedures that gave them slightly better odds of making it home. It was not until after the war, when they heard German accounts of the radar operators' experiences, that many American veterans understood the broader impact of those aluminum strips tumbling through the sky. This gap in awareness was itself significant. Americans could wage sophisticated psychological warfare almost inadvertently as a side effect of operational procedures because their material abundance made such tactics cheap and easy to implement. Germans, by contrast, had to carefully calculate every expenditure of resources, weighing costs against benefits in ways that limited flexibility and innovation. The side that could afford to experiment, to implement multiple redundant solutions, to pursue parallel research programs without worrying about resource allocation, would naturally generate more effective innovations. Abundance created freedom to innovate. Scarcity created paralysis. The radar bunkers, where Klaus Hartmann and thousands of other operators spent the war years, still dot the European landscape. Many have been converted to museums or communications facilities. A few remain abandoned, concrete shells slowly succumbing to time and weather. Inside these spaces, one can still imagine the tension of those January nights in 1944, the green glow of cathode ray tubes, the anxiety of watching signals vanish and reappear without explanation. These bunkers were cathedrals of a faith in technology that was tested and found wanting, not because German engineering was inadequate, but because American industrial capacity was overwhelming. The aluminum strips that defeated the Würzburg-Riese radars disappeared decades ago, corroded and recycled, scattered by wind and weather until none remained. But their impact echoes through modern warfare. Every GPS jammer, every electronic countermeasure, every cyber warfare tool descends, philosophically, from those simple strips of foil. They established the principle that any technology, no matter how sophisticated, can be countered if an opponent has sufficient resources and ingenuity to develop effective countermeasures. They proved that wars are won not by inventing unbeatable weapons, but by creating systems robust enough to function when the enemy inevitably develops counters. For Klaus Hartmann, watching the radar contacts vanish that January morning, the lesson was immediate and visceral, even if he could not articulate it fully at the time. The war was lost, not because of that specific raid, not because of any single failure, but because the fundamental balance of power had shifted beyond recovery. The Americans could make German advantages irrelevant through sheer material weight. They could afford to try multiple solutions until something worked. They could implement crude but effective countermeasures faster than Germany could develop sophisticated responses. This was not the war Germany had planned to fight, built to fight, trained to fight. This was industrial attrition carried to its logical conclusion, and in that contest, there could be only one outcome. The radar screen that showed impossible results that January morning was showing the future, a world where American technological and economic dominance would shape global affairs for generations. The aluminum strips floating through the darkness were harbingers of the post-war order, tangible evidence that free societies with productive economies would outcompete totalitarian rivals in the long run. The chaff was, in this sense, more than a tactical countermeasure. It was a message about the nature of power in the modern world, written in aluminum and scattered across the sky where even the most sophisticated German technology could not prevent it from delivering its meaning. In the silence of a museum displaying a restored Würzburg-Riese radar, one can stand before the massive parabolic dish and imagine it rotating through the darkness, searching the sky for threats. The technology seems quaint now, primitive compared to modern phased array systems and digital processing. But in its time, it represented the cutting edge, the best that German science and engineering could produce. And it was defeated by Christmas tinsel dropped from aircraft, a reminder that wars are won not by the brilliance of individual technologies, but by the depth of the resources behind them, the flexibility to innovate under pressure, and the will to outproduce the enemy across every category of material that matters. The radar operators learned this lesson staring at flickering green screens in concrete bunkers, watching their sophisticated systems defeated by American abundance. It was a lesson purchased with the currency of aluminum strips falling through the night, countless tiny mirrors reflecting a truth too bright and terrible to ignore.